Okay, we're going to start talking about unit number 5, which is about chemical reactions. This is really kind of the heart of the course. We're really going to get into what chemistry is all about. And we're going to introduce a brand new unit to you. So you know units like time and length and height and mass and so forth. This is a really weird unit. This unit is called a mole. And you probably have never heard of it before. It's a unit of chemical reaction. And it's going to be really crucial for us to understand how to predict chemical reactions. It's kind of hard to explain exactly what a mole is. It's an arbitrary sort of unit. One way to do it is 6.023 times 10 to the 23rd molecules. That's weird. That makes no sense. Another way to do it is it's based on the mass and the number of atoms in carbon. That's really weird too. I think the easiest way is just to accept it as being an arbitrary unit. And once you see how we use it, it kind of sort of explains itself. So let's start off by first of all talking about what is a reaction. This is really what chemistry is all about. So chemistry is all about making new things. So if I combine A and B and I run a reaction and I create C, that's really what chemistry is. Chemistry is taking pieces and putting them together in new ways. So we would say, therefore, that the starting material here, A and B, those are the reactants. And the final material that I get out of here, those are the products. And the arrow indicates that we went from A and B, and now we have C. Now later on we'll discover you actually could go backwards, right? Go the other way. And sometimes we indicate both of these arrows simply by an equal sign going back and forth, but we're not going to worry about that right now. So a reaction means we go from reactants, starting material, to products. Now the whole thing about chemistry really is, how do we predict, if I mix A and B, how do I know that I get C? Maybe I get D. Maybe I get E. Maybe I get a combination of all of those. How do you know? And we have a whole bunch of tricks that help us to predict it. One of the tricks will be to recognize the type of reaction. But another trick that we're going to use is conservation of mass. This is a basic idea in chemistry. And all it means is that if you weigh the mass of the starting material, the reactants, it equals the same mass as the final materials, the products. So if I add up the mass of A and B, that should be the same as the mass of C. The reason why it was a chemical reaction, though, is that even though the masses are the same, I've created something new. I started with A and B, and now I made C, but the conservation of mass stays the same. So the way we're really going to baby up on this, our discussion about what a mole is and how to predict chemical reactions, is first of all, how do we make sure that conservation of mass takes place? Well, we have to get back to a basic chemistry idea called molar mass. We have spent a lot of time studying the periodic table. And we learned all about electrons and rings and quantum numbers and these sort of things. But what I want to talk about right now is what these numbers are right here. You see that 1.01 and that 9.01, all those numbers. Those numbers are the molar masses. Okay. What does that mean? Okay. Those are in units of grams per mole. So if we're going to go ahead and try and figure out if conservation of mass takes place in a reaction, I'm not going to figure out, gee, how much did one atom of this weigh, or, handful atom. That's ridiculous. You could never do that. So you need an arbitrary unit. So what these units are, for example, here in carbon, when it says 12.01, that means that 1 mole, let's say a mole is an arbitrary basket here, and if I fill it all up with carbon, how much would this mole's worth of carbon weigh? So 1 mole of carbon weighs 12.01 grams. That is the molar mass. Now usually we're a little lazy as chemists. We like to round things off. I would probably just call that 12 grams for every mole of this. 19 grams over here. 39.950, let's call that 40. Sometimes it's hard to round it off, right? Like this one, chlorine, 35.45, I'd probably call it 35.5. So we're going to use moles to do our calculations, not molecules, but moles. Now, how do you figure out the molar mass of something? Well, if I just said it's pure iron, right, that'd be super easy, 55.85. But most of the time, we're trying to figure out the molar mass of a molecule. How do you do that? You identify all of the different elements, atoms in there, and then you count up how many you have of each one, and you add them all up. Let's go ahead and try some examples of calculating the molar mass of things. How about our favorite molecule? Let's go ahead and do water. We know that water is H2O. So let's first of all identify the elements. I see hydrogen and I see oxygen. How many hydrogens? There's 2 of them. See this subscript 2? And I don't see a subscript here, but in mathematics, when you don't see anything, you assume 1. Same thing in chemistry. So we're going to assume we have 2 hydrogens and 1 oxygen. Okay, I've got 2 hydrogens. So let's look at the molar mass of hydrogen, right? I'm just going to go ahead and erase these guys here, clean them up a little bit, right, so you can see them again. So let's take a look. What was the molar mass of hydrogen? Well, it looks like it was 1.01. Let's call it 1. So 2 times 1, the total mass in 1 mole of water would be 2 grams of hydrogen. How about oxygen? You have 1 oxygen. And what's the molar mass of oxygen? Down here it looks like it's 16. So I have 1 oxygen, and each oxygen weighs 16 grams. 1 times 16, don't need a calculator for that. That's 16. Let's add them up. 18. The molar mass of water is 16 grams for every 1 mole of water. And by the way, since water appears so often in chemical reactions, I usually like to just memorize it's 18 so I don't have to keep doing it. Let's try another one. How about calcium sulfate? Let's first of all identify what elements we see. I see a calcium, I see a sulfur. You always look for those capital letters, right? And I see oxygen. How many calciums do I see? I see 1. How many sulfurs? 1. But wait a second. How many oxygens? I see 4. So let's look at the molar masses. What does 1 mole of calcium weigh? Aha! 40.08. Oh, let's just call it 40. 1 times 40 is 40. That's easy. So far I got 40 grams. How about sulfur? What does sulfur weigh? 32.06. Oh, let's call it 32. 1 times 32, that's easy. That's 32. And how about those oxygens? Oh, I remember that one. Didn't oxygen weigh 16? And I've got 4 of them, so that adds up to 64. Now you add them all up together. So what do I get here? 136. Let's not forget our units. There is 136 grams for every 1 mole of calcium sulfate. So this would be the molar mass of calcium sulfate. So far it's pretty easy. Let's try a really tricky one. Okay, this guy is barium hydroxide. So who do we see here? I see barium, I see oxygen, and I see hydrogen. How many of each one do you see? I see 1 barium now. This is tricky. How many oxygens do you see in here? Well, chemists use the same rules as math. PEMDAS. Use parentheses first. So there's 1 oxygen inside the parentheses, and then we multiply it by 2. So there's actually 2 oxygens. There's 1 hydrogen inside here. We multiply it by 2, so I actually have 2 hydrogens. So I have 1 barium, 2 oxygens, and 2 hydrogens. What does barium weigh? Where's barium? There it is. 137.33. Oh, let's just call it 137. So 137 times 1 is, surprisingly, 137 grams. Oxygen, I remember oxygen was 16. So 2 oxygens times that is 32. And hydrogen, boy, everyone should remember hydrogen. Remember it was just 1? So 2 times 1 is 2. Let's add it all up here. 7, 7, 7, that's 11. That's 7. That's 171. Units, there is 171 grams for every 1 mole of barium hydroxide. And by the way, 1 mole, that's a lot. Usually when we do experiments in labs, we don't use that much there. So the first thing I want you to understand to figure out what a mole is and how we're going to use it is what is the molar mass. Now, there are several different ways we can manipulate molar masses. I just showed you one way. So I just showed you that the definition of molar mass is, let's do the first one here, the mass divided by the number of moles. That's our first equation. But there's 2 other ways we can rearrange these pieces to come up with another equation. We could switch the moles in the molar masses so that the number of moles equals the mass divided by the molar mass. And there's a third way we could do it. We could switch them around so the mass equals the molar mass times 8. Hey, by the way, for you super mathematicians, this is just switching words around just like we do numbers. Let me show you, right? How about this? 10 divided by 2 equals 5. Pretty easy. What if I switch the 5 and the 2? Then I get 10 divided by 5 is 2. That still makes sense. What if I go ahead and switch the 5 and the 2 with the 10, right? Then I get 2 times 5 equals 10. Using the same numbers to get 3 different equations, that's all I did up here. For now, I would go ahead and write these 3 down there before you get comfortable using them. Let's go ahead and try some problems. And what we're going to do in each problem is we're going to figure out what is the unknown, what's the thing we don't know, and that'll tell us which of these equations we should use here. Let's do a couple of sample problems. How about this one? Suppose I have 2 moles of carbon dioxide, and suppose it weighs 88 grams. What is the molar mass? So I want to figure out what the molar mass of CO2 is, right? That's the unknown. Well, which of the equations would I use to figure out molar mass? Aha! I would use that one. To figure out molar mass, that equals mass divided by moles. So let's go ahead and write that equation there. Mass divided by moles. That's how we'd figure it out. So the first thing you do is figure out which equation, just like you do in math and algebra, right? Figure out what equation, then the next step is always put in what you know. Do I know the mass? Yes, I do. It's 88 grams. Do I know the number of moles? Yes, I do. It's 2. 88 divided by 2 is 44 grams per mole. And if you go ahead and do this, CO2 by itself, you could find out that indeed was correct. Let's try another one. Okay, how about this one? Suppose I know that the molar mass of water is 18 grams per mole. If I have 4 moles of water, what is the mass? So I want to figure out mass this time. Which equation would I use? I would use this one. Mass equals molar mass times moles. So let's write that down. Mass equals molar mass, mm, times moles. Okay, so the first thing I do is figure out my equation. Next thing, do I know molar mass? Let's figure, molar mass, it's 18. Remember I told you, always remember water is 18. Do I know the number of moles? Yeah, I know it's 4 moles. So now I know the mass. 4 times this is 72, and our units of mass is grams. 4 moles of water weighs 72 grams. Let's do one more, just a little trickier. How many moles is 117 grams of sodium chloride? How many moles? How many moles? That's my unknown. So which equation would I use for moles? I would use that one. The number of moles equals mass divided by molar mass. The number of moles, so let's write it down, equals mass divided by molar mass. So I've selected which equation I want to use. And now I fill in. Do I know the mass? Yes, I do. It's 117. Do I know the molar mass of sodium chloride? Uh-oh. No, I don't. So I'm going to have to figure it out. Let's go ahead and figure out what the molar mass of sodium chloride is. Remember how to do this? All we do is go back to our chart. What's sodium? Let's find sodium. There it is. 22.99. Oh, let's say that that's 23, shall we? So I have sodium. I have 1 sodium, and that weighs 23. So that's 23. And who's the other guy? I got chlorine. I only have 1 of them. What does chlorine weigh? Chlorine is 35.45. We're going to round it to 35.5. So let's put 35.5 in there, which of course adds up to 35.5. And then we're going to add these guys together, and I get what? 8, and is that 58? 58.5 grams per mole. So we put that in here, 58.5. And if you divide 117 by that, you get 2 moles. And that's how you do it. Figure out what your unknown is. Figure out your equation then. Put in the numbers. And sometimes you need to figure out what the molar mass. This is the first step to understanding how to predict reactions. What we're going to do next time, using the principle of conservation of mass, is we're going to figure out what are the number of moles to balance that reaction.